In this video, we are discussing the various methods of preparation of haloarenes. The first one is from hydrocarbons by electrophilic substitution reaction. So an arene undergoes reaction with chlorine or bromine in the presence of a Lewis acid catalyst like iron or iron 3 chloride to give us an aryl chloride. So here we have toluene. It reacts with X2, where X can be either chlorine or bromine, in the presence of Fe and dark to give us two products, two isomers. That is going to be the ortho and the para isomers. So the ortho isomer and the para isomer are formed, and you know why this particular thing happens. If you don't, again, class 11 gives you the answer to that question. It's actually based on the ortho-para directing group. CH3 alkyl is actually an ortho-para directing group. So electrophilic substitution reaction takes place at the ortho and the para position. So an advantage of this is the fact that because they're two different isomers, obviously they are two isomers, they have difference in terms of their boiling points, and that difference in boiling point can be used to separate these two. Not only that, when we talk about iodine, this particular reaction is actually reversible. So if X is I2, X2 is I2, then this reaction can be reversed. So to prevent that reversible nature of this reaction from taking place, we add an oxidizing agent like HNO3 or HNO4. Now what happens is the HI, which is formed during this particular reaction, will react with HNO3 or HNO4, and that in turn will make sure that the reaction goes in the forward direction. And fluorocompounds are not prepared by this method because fluorine, as we know, is extremely reactive. The second method of preparation is from amines by Sandmeyer's reaction. So primary aromatic amine reacts with sodium nitrite to give us a diazonium salt. This diazonium salt reacts with cuprous chloride or bromide to give us an aryl halide. Remember, this particular reaction is a named reaction, and also this is further discussed in the chapter amines. So when you have aniline reacts with NaNO2 and HX at 273 to 278 Kelvin. This leads to the formation of something called as a diazonium salt, and this diazonium salt is a benzene diazonium halide. Okay, so it has N2 plus X minus. Okay, so this is benzene diazonium halide. So this benzene diazonium halide undergoes a chemical reaction with cuprous chloride or bromide. This leads to the formation of an aryl halide. So you have X, where Cu2X2 because it's cuprous, Cu2X2, and leads to formation of aryl halide plus nitrogen. And the last one is when you have a benzene diazonium halide undergoing a chemical reaction with Ki, this leads to the formation of an iodo group attached. So the iodine gets attached plus the nitrogen. That's it. So the first one was from hydrocarbons. Basically, arene undergoes a chemical reaction with chlorine or bromine in the presence of Lewis acid that like iron or iron 3 chloride, which acts as a catalyst to lead to the formation of ortho and para products. Especially in this case, the ortho para products can be separated because of the difference in boiling points. If you need an iodine group to get added, we need to use a HNO3 or HNO4 as an oxidizing agent, which will make sure that it reacts with the iodine to lead to the HI, and that in turn will make sure the reaction moves in the forward direction. The third thing is the fact that fluorine is a very reactive, and so it does not undergo a chemical reaction over here. The second method is from amines by Sandmeyer's reaction. Primary aromatic amines reacts with sodium nitrite to give us diazonium salt plus cuprous chloride or bromide, gives us an aryl halide. And when we need an iodine to get added, we react it with potassium iodide. With that, we're done with the various methods of preparation. In the next video, we will be discussing the various example related questions related to the preparations of haloalkanes and haloarenes.